Okay, welcome back. In this video, we're going to continue to look at solving systems by graphing. Here we have the equations y equals 2x and 5x minus y equals 9. So we begin, we're going to want to graph our two equations and then look for the point where the two lines cross, if there is one. So we can begin with the line y equals 2x. Very easily we can plug in 0 for x. We get y is 2 times 0, so y would be 0. We plug in 1 for x, and we get y equals 2 times 1, or y equals 2. So we'd have the points 0, 0, and 1, 2. For the other line, we've got to be careful about putting things in for y. Because we put numbers in for y, that's going to lead to us needing to divide by 5, and we'll very likely get fractional points, and we want to avoid those. But what I could do is put 0 in for x, and when I do, I'd have negative y equals 9. So y would be negative 9, so I'd have the point 0, negative 9. And then pick some other value for x, let's say maybe 1. Well, if I put 1 in for x, that would be 5 minus y equals 9. Could subtract 5 from both sides, get negative y equals 4, and then finally get y equals negative 4. And so we'd have the point 1, negative 4. So now we have 2 points for each of our two lines. And at this point we go ahead and we start graphing. So for y equals 2x, I could graph the point 0, 0 and the point 1, 2, and then draw the line that goes through those 2 points. And then for the second line, 5x minus y equals 9, I could plot the points 0, negative 9, and 1, negative 4. And then draw the line that goes through those 2 points. And then what I'm looking for is, where do they cross? Well, they cross at that point. Okay, they cross at that point. And what are the coordinates of that point? Well, the x coordinate is 3. The y coordinate is 6. And so we have the point 3, 6 as our solution. Go back to your two equations, plug 3 in for x and 6 in for y. You'll see that it works for both of them. Y equals 2 times x. Well, 6 is equal to 2 times 3. If you go into the second equation, 5x minus y equals 9. Put 3 in for x. You'd have 5 times 3 is 15. Minus y, which is 6. 15 minus 6 is equal to 9. And so that is the solution. Now, as I mentioned before, graphing isn't the most effective of methods for solving a system, particularly if your answers turned out to be fractions. It would be really hard to judge from a graph. Is it really a half, or is it a quarter? Or is it a third? Or is it really 2/5? Yeah. Which one is it? But one of the things we can get from graphing is an understanding of what can sometimes happen with systems. So there are two special cases that we sometimes encounter other than the lines crossing at a single point. One is that you could have your two lines be parallel lines. Now we know parallel lines never cross each other. So since these lines never cross, this system, a system consisted of parallel lines, would have no solution. The other possibility, look carefully, here's line 1. Now very carefully, here's line 2. In other words, the two lines coincide with each other. Well, in that case we have the same line, and that would actually mean that any point on the line would work. Since there's an infinity of points on the line, this would have infinite solutions. Now, one last little note before we conclude things. When you're doing these problems on MyMathLab and you're asked to solve by graphing, what you're going to want to do is you would graph your two equations and then look for the point where they cross each other. Look for the point where they cross each other, and that will be your solution to the problem. So again, if you're doing them on MyMathLab, you use a graphing interface just like we did before. You would graph each of your lines and then look for the point where your lines cross. Okay, till next time. In the next video, we'll be looking at one of the methods that we can use to solve a system. It'll be called substitution.